Okay, so we're recording now. Recording, and I can't, there we go. Okay, so what I'm going to talk about today is sort of the fundamental issues, the fundamental issue that we deal with in trying to figure out cause and effect, and then how we do that. And sort of the gold standard for that is that we want to use experiments. In the hard sciences, that's almost all they do, um, for the most part. Um, there is some observational study, but they're heavy on experiment. In the life sciences, it's a lot of experiment, but they also do some observational study. So field work, they go out in the field and see what's going on. Biologists and people like that go out in the field and actually observe animals. That's more of what we do, is actually go out and observe humans. We do some experimental work in political science, more so when it comes to comparative politics, when it comes to political psychology is big on experimental stuff. Um, but when we get into comparative politics or international politics, a lot of what we have to do is observational, going out, observing in the field, or in a lot of cases, not even observing in the field, taking some data that's available and applying it to figure out what's going on. Um, and and we have to do that because human beings are hard to experiment on. There are lots of reasons for that. Um, so um, I'm going to talk a little more about that, and I'm going to talk about what our goal is, and when we do experiments, how we should do them, and then some of that will also apply to the non-experimental stuff. Um, the whole point of all of this is that we're trying to get at cause and effect. That's what science is about. Not trying to decide on some platonic higher plane the way the world should be. That's the province of ethics and moral philosophy, and political philosophy. And you can take that plane, the political philosophy, and you can combine it with the science when you're trying to figure out policy. I think probably you should consider that when you're trying to figure out policy, not just science, but it's a separate thing. And we're in the science half trying to figure out what causes things. Um, to start with, we really should start with the idea of what is a cause. So a cause is the essential thing, without which the outcome, why, cannot happen. So if you think about a house fire caused by lightning striking the house, it's the lightning that is the cause. Or I think in the legal profession, they'd call it the proximate cause. It's that final cause. It's the spark that starts the fire. Actually, that's the spark that starts the fire is like the example of the cause. There are lots of other things that go into it. A fire's not going to happen if you don't have oxygen. A fire's not going to happen if you don't have fuel. But you can have all the oxygen in the world and all the fuel in the world, and something has to provide a heat source to actually start that fuel burning. Um, and that spark is that immediate cause. The oxygen, the fuel, those are conditional causes, so they're important. And a lot of what we have to do in behavioral research is figure out what are those conditional things, because without the conditional things don't happen. The conditionals, things don't happen. So if your fuel is in a vacuum, no oxygen, and you apply a spark, it doesn't burn. And we have to be careful with behavioral research that we don't say, oh, we applied a spark and nothing happened, therefore we have to throw the whole theory out, because sometimes we don't know whether we have the oxygen, the condition that makes it happen. Um, And so, but mostly we're looking for that spark. And there can be different sparks too. This is not unique to political science, um, but sometimes we forget it. We say, well, here's a case where this happened and there was no lightning strike. Well, okay, there was faulty wiring, or it was arson, or, or the stovetop fire, or whatever. Yeah, not all house fires are caused by lightning strikes. In fact, most fires aren't caused by lightning strikes, but we still know that lightning striking a house can cause a fire. In political science, a lot of times we forget that. We say, oh, well, here's a case of a country where this happened, and the thing that is proposed as a cause didn't happen, so it must be wrong. That's a little too closed-minded when we think about what a cause actually is, and the fact that there can be different causes for the same effect. Um, but ultimately, our goal is to say, hey, we've got this cause that we think happened, that we think made this effect happen. How do we get there? Um, and the single biggest issue that we have in getting to that is that the fundamental problem of causal inference. And the fundamental problem of causal inference is that we can't observe the counterfactual. And what does that mean? So the factual is what actually happened. So Donald Trump was elected president in 2024. We can call that the factual. We can't observe the counter case. We can't observe Kamala Harris elected president in 2024. So if we want to talk about what caused Donald Trump to win, we don't have the opportunity to observe the opposite case. This is a huge problem. This is a problem. This is a problem for trying to do research. It's often a problem for people looking at research or even conceptualizing research. You think about in the real world when people talk about, well, um, you know, uh, I don't know, the United States has high levels of gun ownership, and relative to other countries, high levels uh, of some violent crimes relative to some other countries. Um, we can't observe the counterfactual of the United States not having high levels of gun ownership. If we want to say that the higher levels of violent crime are caused by high levels of gun ownership, which many people want to do, we can't actually, observe what would happen if the U.S. didn't, because we're not able to do an actual experiment, which is going to be the gold standard. The gold standard is the experiment. Um, so we can observe with the treatment. So in the case of violent crime and gun ownership, if gun ownership is the treatment in the United States, well, we can observe that. But we can't observe it, the unobservable. And a lot of people, of course, especially in comparative politics, the immediate response is, well, we compare to countries that don't have the same level of gun ownership. But that's a very imperfect, if that's all we do, it's an extremely imperfect comparison because there are lots of other factors. And in comparative politics, at the very base level, what we do is we try to isolate by finding a country that is in every other way comparable, but doesn't have the gun ownership. Of course, finding a country that is in every other way comparable to the United States is going to be impossible. The United States is, in many ways, a unique case. The economy is so big that it's bigger than any other country. The history is different in significant ways. And I'm not talking necessarily about American exceptionalism, like it's, that kind of thing, but I'm just, by its size, by its economic power, by its military power, by its history, you're going to have a very hard time finding in another country that you can say, yeah, they're comparable in every other way. So that's the real world. That's the real world problem for just going out and observing things. What's our solution? Our solution is that we construct a counterfactual. We do it through random selection and random assignment in something called an experiment or a random controlled trial. And in a random controlled trial, we have a group of experimental subjects, and we randomly assign this group to two different groups. One is the treatment group. That's the factual. They receive the treatment. The other is the control group. They don't receive the treatment. And we do this in a controlled setting so that we can make sure that there are no other outside influences coming in. And the random assignment allows us to produce groups that are fundamentally similar, that share every other aspect except for the treatment. This is done all the time in clinical studies. They'll take a few hundred people with some condition. Well, they start with safety trials where they take just healthy people and see if it's safe. And they split them into treatment and control. But when they get to testing whether something works to treat an illness, then they split the group into a control group who does not receive the treatment and the treatment group that does. And the reason is, well, there are a couple of reasons. Number one, some percentage of people with most illnesses get better spontaneously. The second reason is there's this effect of if you receive the treatment, if you are receiving a treatment, you think you're going to get better. So they give the control group a fake treatment called a placebo. So in an experiment, things are as tightly controlled as possible. And when we start doing things like survey experiments, they can be done in a lab where everything is tightly controlled. And how do you, in a survey experiment, deal with the fact that people come in with different levels of knowledge? So if we do a survey experiment about some political issue to see how people respond, how do we deal with the fact that people may come in with different levels of political knowledge or different preconceived opinions? Well, that's where randomly assigning them to a treatment group and a control group handles that. Because if we do the random assignment properly and we have a large enough group, then all of those what if things, all of those, well, maybe this affects it things should equal out between the two groups. And if we do this, then this is absolutely the gold standard on internal validity. We know that within the experiment, within the study, things are valid, that it is correct. Why? Because we control the treatment, the manipulation. So the treatment, another word for it is manipulation. We control it. If it's, giving a drug in a medical trial or showing people a certain picture in a political psychology experiment, we control the treatment. The random assignment takes all the other little things that might be out there, the age, income, motivation, all of these other things that might be different between the groups by randomly assigning, we split those between the groups. Assuming we do our random assignment properly, assuming it's truly random, and assuming that we have large enough groups to catch all of those other things. So you can also think about demographic factors. So if we do random assignment, that should be taken care of. We can also keep track of some of those easy to track ones. So like if we do the random assignment and we find out that we somehow randomly ended up with groups that are not racially balanced, then maybe we have an internal validity issue. So we can track some of the big ones. And random assignment sometimes can produce groups that are different, but overall, if the groups are big enough, it shouldn't happen. And that goes to the whole thing of distributions and central limit theorem and all of those things. As the groups get bigger, as the sample gets bigger, the better off we are in terms of catching all the random stuff. And the result of this is that the only difference is the manipulation. The only difference is that we gave the drug in a medical trial, or that we showed the picture in the political psychology experiment. The only difference is the difference we caused, the manipulation. We also do, in order to get external validity, and external validity is how does our experiment apply generalized to the people that aren't involved. So we do our experiment if we're on 250 subjects. How does our experiment then generalize to the other 7 or 8 billion people in the world? If we only did 250 subjects, how do we make sure that it generalizes to everybody else? Or how do we make sure that our survey of 1,000 people generalizes to the entire United States? And that could be for a survey experiment. It can also be for a political survey. And the two things that do that for us there are, again, sufficient sample size, which is a statistical question we can solve, and then random sampling. We pick the people that are even going to be involved in the experiment, the survey, randomly. So if we're going to do this experiment where we show people a picture and then we ask them questions to determine the effect of the picture, the first step is, out of all the people who would take the survey, potentially, we should actually be getting a random sample, not a what they call convenience sample. So a convenience sample is the one that you probably have seen a lot. You may have been involved in. It's a professor tells your class, somebody else in the department is doing some research. They need some people to take a survey. You can get some extra credit if you take this survey. Or you're walking around campus and you see one of those little signs that says the psychology department needs subjects. You can make $50 for 2 hours of your time. And you go to the psychology lab and they run some experiment. There are external validity questions with those convenience samples because they're not randomly sampled. There are ways to make those better. I'm not going to go into those a lot, but the gold standard, if we really want to do an experiment right, is we pick our subjects and we do it randomly. So we have random sampling going in and then random assignment between the control and treatment groups within the experiment. And the whole point of this is to eliminate anything that would bias the experiment. It's to make sure that we get groups internally that are the same and externally that reflect the population we're interested in. And the same goes with just surveys. If we're trying to determine political opinions in the United States. We want to make sure that we do random sampling so that we get, in fact, with surveys, we don't have to worry about the control and treatment group. That doesn't happen, but we still do the same kind of random sampling to ensure that it's externally valid, that it applies to the United States, and not just to the group that's involved. So what is random sampling? Random sampling actually has, there really are 4 different major methods, and there probably are minor variations of these too. But the 4 major methods are, number 1, simple random sampling. Every possible subject or group of subjects has an equal probability of being chosen. So if we're doing either a survey or a survey experiment, it would be, we look at the population and we use a random number generator to pick people. And then we go ask them the question. This is absolutely unbiased. It's straightforward in that you can show it and it is obvious that it was real random sampling. The problem is you have problems. You have to have an actual complete list of the population, and you have to find people willing to answer your questions. Like the random sample has to be willing to answer your questions. One of the problems with political polling recently has been that it's tough to get people to answer your questions. And if that were a problem with everyone equally, it wouldn't be a problem. But sometimes that unwillingness to answer questions itself has bias. So for example, the 2016 election, there was bias in that many Trump voters were unwilling to even answer surveys. And if they did answer surveys, they didn't answer honestly. Now, that's a second question, but in terms of the random sampling, many of them, knowing that they were going to vote for Trump, knowing that that was considered not acceptable socially in their social circles, would just not answer surveys. And so it led to a bias, and it led to that idea that the election was stolen from Hillary Clinton because all the pre-election polls showed her with a comfortable margin, not an absolute one, but a comfortable one. So this is the issue with random sampling. If you have a group where you can force people to answer, or where you're certain that everyone will answer, this is the best thing. It's the best thing possible. But it doesn't always work. And it's tough anyway. Even if you had that list for the whole population, and even if everybody would answer you, it can still be difficult. One of the ways that we used to get around this was something called systematic sampling. The issue here, or the method here, was you pick a random place to start, and then you go with every 10th person or every 100th person. If you wanted to sample, 1% of the people in Harris County, you would get a phone book, or they actually used to have a specific kind of phone book that showed everybody. It was one you had to pay for, but it would have all the numbers, and it would have a reverse lookup with addresses and everything, and you could get that phone book, and you would, instead of calling every number, you select randomly a page, and then select randomly what person on the page to call, and you start there. And if you want 1%, you start with the one you randomly selected, and then every 100 after that, throughout the rest of the book, gets called. And then when you get to the end of the book, you come back to the beginning, and you go until you get back to the page you started with. So So that's systematic sampling. Um, if you do that by address, there can be hidden patterns. Like if you're not doing phone calls, if you're doing addresses, um, and you end up leaving a neighborhood out, because a small neighborhood out, maybe where there's a group of people who are related or not necessarily related directly, but like if you leave out a if you're going to every 500th door, which might be reasonable, um, you might bypass 400 people who are mostly immigrants from a particular country. It would be very easy for something like that to happen in a city the size of Houston, that has the diversity it has. If you're not careful, you could skip a group of people who have chosen to live together because of an ethnic background, an immigration background, a language background. Um, Most of those groups are big enough you're not going to skip them completely, but you can leave out a large chunk of them. So that's an issue with systematic sampling. The other issue with it is you can still do it with addresses. You can't do it with phone numbers anymore, because so many people don't have a landline, and even people who have a landline often don't answer it for numbers they don't know, um, or don't answer it at all. Um, the last several years that I had a landline, the only reason I had it was for my internet connection, and I had a cell phone, and I did not answer my landline. I didn't even, for the last few years, I didn't even have a phone connected to it. Um, so, you know, nobody would have ever gotten me if they'd have done the phone book thing. And I was in the phone book, but, nobody could have called me. Um, The next one's stratified sampling. So this is still random sampling, but it's stratified random sampling. And the way this is done is you start by sorting into groups, and then you take a sample from every group. So for example, if we wanted to, if we had the information available and we wanted to make sure that all minority groups were represented in a survey, then we could sort into minority groups, and we would probably do it by size relative to the population, um, in order to make sure that it was not overweighted one way or the other. So we'd have to weight the strata by population size, but we sort into these strata or groups, and then we go in and randomly sample the groups. So the first stage is not random. It's sorting into groups in order to make sure that the random part gets every group. Because if we're doing completely random, it is possible. It is not likely if we have a large enough sample, but as our sample size gets smaller, there is the possibility of randomness leaving something out. And so we do stratified sampling. This is common. This is common with polling. They want to make sure that the representation of various groups is consistent, so they may do stratified sampling. Another one that's also somewhat useful in polling is cluster sampling, which is randomly selecting the group and then surveying everyone in the group. So this would be randomly selecting voting precincts. You want to do polling, so you randomly select which voting precinct you're going to poll in, precincts, and then you go and you knock on every door. And if they don't answer, you come back and knock again until somebody talks to you in the voting precincts that you pick. So this is cheaper and faster because you don't have to spread out over as big an area. So if you're talking about like voting precincts, you drive to that voting precinct. You don't have to go to all the different geographical areas. Much more chance for error because those voting precincts can have this possibility that it's much more likely that you're going to leave out important demographic groups if you do this. It's still random, so you shouldn't. But when you group people together in big ways like that, the possibility of leaving out some important demographic group is higher. It's like the second case. It's like systematic sampling in that case, except even more of a chance that you're going to leave out that neighborhood where everybody shares something in common. Stratified sampling, if you want to do that, is more precise. It's going to be higher cost, though, because when you do your stratified sampling, you're sampling on characteristics, which means you're going to have to go out to all the different geographical locations to make it work. Stratified is you cover all the area and you pick certain characteristics to group people by, and then you randomly select from within the groups. The clustering is you just pick areas or you pick groups randomly. You definitely would not want to cluster your cluster sampling. Really, the main way that this is feasible and defensible would be the geographic cluster sampling. You would not want your clusters to be ethnic groups, and you randomly pick which ethnic group to sample. That would be a horrible research design because you would be leaving out a major characteristic that we want randomness to account for. So you would be achieving the opposite of the effect of random sampling. So cluster sampling, the best use case for is going to be some kind of geographic clustering. And even then, you've got to be careful because it's prone to error. So simple random sampling, the theoretical ideal, expensive, hard to do. Systematic, much more efficient, but there's a possibility that patterns in the data can bias things. So you've got to be careful of patterns. Stratified sampling, very precise. The analysis is complex. Setting up the groups is complex. You have to, on the front end, you have to set up the groups properly, and on the back end, you have to analyze it properly. Cluster sampling, much less precise. It's budget friendly. It's time friendly because you pick a geographic area. You have to fit your budget, and you have to fit your purpose. So deciding which to use is a matter of what resources you have and what's the question you're trying to answer. With regard to experimentation, generally, experimentation has limits. One is ethical. If you're experimenting on humans, first of all, to do it in an academic setting, you have to pass the Institutional Review Board, the IRB. You have to present your experiment, even if all you're doing is a survey. You have to present it to the IRB before you start. Even if you're interviewing people, you have to present that to the IRB before you start. So anything you do with human subjects has to be approved in advance to make sure that you're not harming people. It may also be impossible. You can't randomly assign war. You, generally speaking, are not going to be able to go out and do experiments on members of Congress. So there's one study I know of that did a survey experiment with members of the Israeli Knesset, the Parliament of Israel. Um, and that was, that was amazing, because it was the one situation where someone actually experimented in a survey experiment on politicians who were actually in office. Generally speaking, you can't do that with politicians. Um, that you're not going to be able to do an experiment with them. And that one was a survey experiment. So even then, it wasn't a super experiment. It wasn't randomly assigning Republicans and Democrats to different districts or something. The second issue with experiments is external validity, and we deal with most of that with the random sampling. But there still is the question of, if we're doing a survey experiment, does that really apply to the real world? If we bring people into a lab, or if we have them at home on their computer answering questions online, and we show them pictures and then we ask them questions about it, or if we show them a news article and then we ask them questions, does that really translate to how they're going to behave outside the lab? Cost is also an issue. Experiments are expensive. If you're going to do a lab experiment, you have to bring people in there. This is the reason that they use convenience samples, like the giving some extra credit in American government classes to get people to come answer a question. Because actually getting random people in is expensive, and even some of the convenience samples are expensive. So they'll pay people to take a survey online, or paying people to come in to the psychology lab for a couple hours for $50. That's expensive. But even getting people to take a 15-minute survey is expensive, especially if you want to get a good sample, because your good sample, to be a really good sample, especially for political issues, it needs to involve some wealthy people. And so offering $2 for a 15-minute survey, I had one of those the other day. I'm not even wealthy, but I'm not going to take $2 for spending 15 minutes out of my time. If I have 15 minutes free, I want more than $2 for it. And I'm not even wealthy. So think about somebody who makes $250,000 a year. They're just going to laugh at $2 to take a 15-minute survey. So to get people involved is expensive, especially if you want a good sample. So in the ideal world, we'd have these perfect experiments with unlimited budgets, absolute access to anybody we wanted, able to do almost anything. We can't do that. We can't do that in almost all cases. You think about the big political cases, war and peace, election outcomes, economic changes that affect politics. We can't make these things happen. So we watch for the world to do it, and then we do observational studies about what happened. And if we're really lucky, we can do observational studies that allow us to observe things that are natural experiments, where the things that happen in the real world do the assignment for us as if it were random. That's the top level of observational study, the one where nature has randomly assigned the treatment effect among groups that are, similar enough that we have a control group and a treatment group. If we can't get that, then we start to do things like synthetic controls and other things, and control variables, looking for additional variables beyond the X that are measurable, and trying to take into account as many of those other variables as we can. That's that may not be the next lecture, that may be 2 lectures down the road, but within the next lecture or two, we're going to talk about those natural experiments and observational studies. So I am going to escape this, and I'm going to, oh, I guess I had one more slide. I will, yeah, that's all right. I'm going to escape this, and we will, I will take questions after I stop sharing or stop recording.